Hello everyone, this is a KTaNE tutorial for the module hexNull. This module does not require any edge work, so we can just get right into it. So, here's how the module works. Basically, there's a 4-layer binary tree that looks like this, sort of. And you start at the top node, and each arrow you press on the module moves you either to its left or its right child node. And each time you reach a node in the bottom layer, something happens, but we'll get to that in a moment. Each node on the bottom layer is indexed starting from 0 on the left, and moving right it increases. And each node on the bottom also contains a binary bit that starts at 0 for all of them. Also worth mentioning, it just so happens that when you take the indexes of each of those nodes and convert them to binary, you'll get the exact directions you need to take to reach that node, with 0 being left and 1 being right. So for example 5 converted to binary is 1 0 1, so that's right left right. And well, we go right from there, then left from here, then right from here, and we do indeed reach 5. So that's something to keep in mind. Now, when you press this big button, which you can do freely as much as you want, with no consequences, you'll hear a sound, and I'm gonna actually up my game volume for this. Maybe not music, just sound effects. You'll hear a sound, and you'll see a square with a line through it. And you need to note if the sound is low or high, if the square is black or white, and if the line going through the square is vertical or horizontal. So, for example, that was a high sound, black square, horizontal line. High sound, black square, vertical line. Low sound, black square, vertical line. Low sound, white square, vertical line. There are two other things that the button also does. One is bring you back to the top of the binary tree, so to right here. And the other is related to the message that you get when you press it, and it's the key part in solving this module. Basically, there's an entity that moves to a random node in the bottom layer every time this button is pressed. And the message that you get, and the binary that you can convert it to using this table, tells you which node exactly it is in. So, right there it was high sound, white, vertical. High, white, vertical, which is 1 1 0. So the entity is currently in node 6. Also, one thing to note, that this binary is actually exactly the same as the binary that tells you which directions to take, because, well, if you convert it to decimal to figure out which node it's connected to, and then back to binary to figure out the directions, you're just gonna get the same number. So we got 1 1 0 from the table. So to get to the entity, we need to go right, right, left in this case. Yeah, the first thing we need to do is get to the same node as the entity. And once we do that, we will be given the location of 4 nodes in binary as colors, where black is 0 and white is 1. And we need to note that down for a later step in solving this module. So let's go right, right, left. We get 1 0 1, 1 1 0, 0 0 0, 0 1 0. This converts to 5, this converts to 6, this converts to 0, and this converts to 2. Now I'm gonna make an array of 8 binary digits, labeled with indices as in this tree. And for each of the numbers that I got from the module, I am going to invert the bit at that position and the 2 bits adjacent. So, for example, I got a 5 here, so I'm going to invert these 3 bits, so these zeros are become 1s. 6 means I invert 5, 6, and 7, so this becomes a 0, this becomes a 0, this becomes a 1. Also note that this wraps around, so in case we get a 0 like this, we invert 7, 0, and 1. 0 and 7 are because they're adjacent to each other. So 1 becomes 0 here, and these 2 zeros become 1s. And lastly, the 2 inverts these, so 1 0 0 becomes 0 1 1. Once you do this, you should always have 4 1s and 4 zeros in your array every time. You'll have 4 of each. Now, the 4 bits that are 1s in our array, so in this case 0, 2, 3, and 4, are the bits we need to flip in this binary tree, and then submit our answer. And here's how we do that. So, whenever you reach a node at the bottom layer that isn't the location of the entity, both the bits at your position and at the entity's position get flipped, so changed from 0 to 1 or 1 from 0. So for example, the entity right there was at 6, so if we went to 3 instead, this bit here would become a 1 and this bit here would become a 1. Yeah. So we basically flip 2 bits at a time by doing that. So what we need to do is first make sure the entity is at a bit we need to flip, and then go to a different bit and repeat that 2 times. So, for example, let's see. We can now press this button again to get us back to the top and move the entity somewhere else. That was high, black, horizontal. High, black, horizontal. That's 1, 0, 1. That's 5. That's not useful. We need to invert 0, 2, 3, and 4. Let's reset again. High, black, vertical. That's 4. That is one of the bits we need to flip. Let's go 3 lefts to 0. As you can see, it says written to nodes 0 and 4. So that means these 2 bits are now 1s. Now the bits we still need to invert are 2 and 3. That's going to be either 0, 1, 0 or 0, 1, 1. So it's always going to be low pitched and white. Just like that. Low pitched, white, vertical. That's 0, 1, 0. So 2. This one. We go to 3. So left, right, right. Inverted 3 and 2. So now these 4 bits got inverted. Just like we needed them. And now, one thing I forgot to mention. Once you invert any bits like this, going to the entity no longer shows you the binary and instead submits what you have currently. So that's also something to keep in mind. But now we've inverted all the bits we needed to invert. So now we can do this one more time. That was low black vertical. Low black vertical. That's all zeros. So we can go left, left, left to the entity. And the answer was correct, so the module was solved. So you may have noticed that I didn't actually use the concept of a binary tree much, mainly just the bottom layer. That's really the only part of the binary tree we care about. So, and we also know how to get to each of those nodes by converting the binary of its index. So all we really need to do is find which 4 bits are going to be 1s after the array modifications and then invert those, and that's it. We don't really need the binary tree for anything. It's just... we can just simplify the module like this. So let's go through another example. Alright. That was high, white, vertical. So the entity is at 1, 1, 0. So right, right, left. That's 1. That's 0. That's 4. And that's 5. Okay. So this 1 is going to invert 0, 1, 2. This 0 is going to invert 7, 0, and 1. Remember, 0 and 7 are adjacent. This 4 is going to invert 3, 4, and 5. And then this 5 is going to invert 4, 5, and 6. And because those are binary bits, after we invert them twice, they cancel out. So these 0s are going to cancel out, these 1s are going to cancel out, and these 4s and these 5s. These 5s. So these are the bits we need to invert, basically. So let's do that right now. Let's see. Low, white, horizontal. Low, white, horizontal. That's 0, 1, 1. That's 3. Okay. Let's go to 7. Now we still need to invert 2 and 6. That's going to be either 0, 1, 0 or 1, 1, 0. So it's always going to be white vertical. This is a bit of RNG. It's kind of annoying to deal with on TP because it's a 1 in 4 chance that you get the entity to actually be where it needs to be. There we go. Low, white, vertical. That is 0, 1, 0. So 2. We can go to 6, which is 1, 1, 0. And And now, that was high, white vertical, 110 again. Let's submit. And we're done. So, this module really is not as intimidating as it looks. You just kind of have to deconstruct it like that and it becomes pretty simple. It's actually quite a fun solo too. Alright, that is the tutorial for hexNull. Hope I helped you understand the module and see you next time.